All right. Hi, everyone. Welcome to what I think is the last Ceph Developer Summit session. This is a session on RBD. Overall, for Tentacle, I think we have kind of two major buckets of work. It's RBD mirroring and built-in LUKS encryption plus live migration. The two may seem orthogonal, and they are, but the work that is ongoing and is planned for the rest of the Tentacle cycle makes the two kind of tie together. And then there are a couple more fixes on the edges that I really want to get to. And towards the bottom of the pad, there is a small section on the kernel client, which neither of those two items are actually specific to RBD, but I think it's something that we'll need to do regardless. So the first topic or the first item is snapshot-based mirroring for consistency groups. This is something that the RBD team has been working on for a few months now. There is a main PR that Prasanna is working on. It's still work in progress. And there are a lot of to-dos and fix-me's, both on the code side and on the test coverage side. And then we have a couple of items that were kind of broken out, the sorted group snapshot listing and the group mirror snapshot scheduler, which are being worked on by Nitya and Ramana, respectively. Prasanna, do you want to give a kind of short status update or summary for the main PR?
Yeah. Thanks, Ilya.
I think
Consistency groups.
I'm sorry, is it just me or the pad just? Oh, you switched the tab.
Yeah. Sorry. Yeah.
Okay.
Back to it. Consistency group snapshot mirroring. A major portion of the code is ready. That is to say, all the functionality is equipped within the PR, which is under review now. I would say some more touch-ups on the items like handling group force promotes gracefully is pending, and then there are a few pieces like mentioning of parameters like parameters on the group status description, like the snapshot timestamps and the last sync seconds, etc., is pending. And then we have to finalize on the API schematics. There are some more discussion there, and some more things like the resync metadata object, which object to be used, and decisions like that need to be is also pending, and some more additions like the unit test additions is pending, and more testing and stabilizing is in progress. And as this is a very huge PR, I think like the reviews and stabilizing will take some more time. As Ilya already mentioned, Ramana is working on some pieces like the group snapshot scheduler. Nitya is helping majorly on the reviews and the snapshot listing pieces. That's where we are. Back to Ilya. Thanks.
And I think the most concerning piece is probably force promote. You've said that I mean, there's no such thing as a graceful force promote, really, right? So it's always like if it's if with snapshot-based mirroring, force promote means a rollback, which which is an operation that can potentially make the image on the secondary, or the images in the secondary, the entire group in this case, it can make that, potentially less consistent than the user would have liked, because we don't have a notion of file system, or let alone application level consistency here. These snapshots are only crush consistent, and the only thing that the group kind of contributes on top of a regular snapshot on a standalone RBD image is that those snapshots are kind of crush consistent between each other. So it's the same kind of point in time, but it's not, as far as force promote, it still involves a rollback. And I don't think like that's something that we don't really have a test coverage for. And when I was talking about test coverage gaps, I think that's the primary one that's on my mind. And in general, I think you've covered the kind of mostly the code part of it. I think the tests would need to be improved a lot, because what's currently there in the PR is very simplistic, and there's no, not even a hint at thrashing anything. It's just isolated test cases that do just one operation at a time, and I'm not sure. Did we make a change to actually test groups with multiple images there? Because I think at one point it used to be that the only thing that was covered is a group with a single image in it, which is obviously not adequate. Is that done?
And to say no, I mean to say like that we have multiple groups testing in place, but they still use the single image pattern.
Yeah, that would need to change.
Yeah.
That's the second kind of major item on the list of kind of on the test coverage list.
Okay, noted, Ilya. Thanks.
Well, moving on to the sorted group snapshot listing, I think it's very close. Nithya, do you want to say something about it, or just leave it at very close?
I think we can leave it at very close. Once your comments are addressed, I think it should be okay.
All right. And the next one here is something that Ramana is working on. Since we have a mirror snapshot scheduler for individual images, this is a Python module that is running in the manager daemon. It's actually part of the RBD support manager module. We need equivalent functionality for groups, because this snapshot scheduler is actually being used on the Kubernetes side by Ceph CSI and ODF. So we need equivalent functionality for groups, and this involves not just the actual Python code to do that, but also extending the APIs that are currently present in the main PR to make some of them asynchronous, because that's what we need for a single-threaded Python module. Ramana, do you want to give an update there?
Sure, yeah. Yeah, as Ilya mentioned, the tricky bit has been making those APIs that the snapshot scheduler would be calling asynchronous, like the create mirror group snapshot and and getting group info. So I've been working on that. The main PR that Prasanna has been working on is being used as the base, and I've been working on it. Some of these APIs that I've been trying to fix as well, because there have been some issues. So the snapshot scheduler in and of itself, the group mirror snapshot scheduler, the code shouldn't be too complicated, because we already have a mirror image mirror snapshot scheduler. So we'll borrow lots of code from that. But these APIs have been tricky to implement because they're still being developed upstream. That's mostly it.
Sunil?
Yeah, hi, Ilya. So does it support both individual mirror image snapshot scheduling, also both the group level snapshot scheduling?
Well, the individual image scheduling is supported today. And what this work is about is kind of adding the same level of support for groups. And then for images that are part of the group, if that group is enabled for mirroring, the schedule that is configured on that group would apply, to all of the images in that group. They will be mirrored on the same schedule. There would like if you're asking whether there's going to be support for somehow mirroring those images at kind of different schedules, no, because that's like the point of introducing a scheduler for groups is to to take group mirror snapshots on a schedule, and once a group mirror snapshot is taken, that translates into the corresponding snapshots on the images that are part of the group, and then those snapshots are replicated basically as part of replicating the group snapshot. So it's hierarchical. There is only one level, but it is hierarchical, and the snapshot scheduler is going to work on groups, and I assume there's going to be separate sets of commands. So the schedules for images would be separate from the schedules for groups, and would be managed with with a command would have a different prefix. Right, Ramana?
Yeah, that's correct.
Okay. Yep. So basically, group scheduler will be overtaken by each individual scheduler.
No, there's going to be a single a schedule is configured for a group, and then the group scheduler takes group snapshots according to that schedule. It's not going to interact with individual images at all.
No, but if the user initially scheduled for individual images, and then if they schedule it for a group, at that time, which one it will take?
An image cannot be, an image is either mirrored individually or it is mirrored as part of the group. It cannot be both. And that's something that is going to be, we've talked about disallowing the sort of transitions where if mirroring is already enabled for an image, in order to add it to a group that is enabled for mirroring, that kind of individual image mirroring would need to be disabled first.
Okay.
So at least for the first iteration, we're going to put all of these kind of restrictions in place where it's going to be very explicit. So if you're moving it from a scenario where it's mirrored individually to a scenario where it's now part of the group and you want that group to be mirrored, that's going to be a manual step where you need to disable mirroring on the image and then enable mirroring on the group. But
okay,
that has some kind of, that is potentially inefficient though, because disabling mirroring on an image would mean that everything that has to do with that image, like including the image itself on the secondary cluster, everything's going to get cleaned up. And this means that the same image that has just been added to a consistency group is going to have to be resynced from scratch, as opposed to just a small delta indicating that this image is now part of the group getting synced. So going forward in the future, definitely not in Tentacle, and but maybe in some future release, I think it would be good to eventually get rid of these restrictions, possibly one by one incrementally, and make it so that if an image is already enabled for mirroring, then it can be seamlessly added to a group, and that's going to be picked up, and no resync would be required. But it's not going to be. It's definitely out of scope for Tentacle.
Okay. Yeah, but only one suggestion is like instead of disabling the existing mirroring and then enabling for group snapshot, is there any other better solution without disabling, because IO will be interrupted for that user?
No, IO would not be interrupted. The act of disabling mirroring or enabling mirroring on a primary image does nothing to the workload, to the IO stream. What is impacted, like when mirroring is enabled, it's just like a sync is scheduled. So at that particular point in time, nothing happens. But when mirroring is disabled, like I said, what happens is the image is cleaned up on the secondary. It's still there on the primary. So if the workload is running, it's not disrupted. All of the IOs proceed as usual, and get completed as usual. What happens? The only thing that happens, is that on the secondary cluster, that image gets cleaned up, and some metadata is obviously updated, but that is not disruptive to the workload. If, however, you disable mirroring and then almost immediately re-enable it, whether explicitly or by virtue of adding an image to the group which is enabled for mirroring, that's a problem, because at that point a resync is scheduled. So and you end up resyncing the entire image from scratch, instead of like I mentioned before, just shipping a small delta over the wire. There's no way to get around this currently, because there's no kind of handover between the image replayer and group replayer concepts in the code as it is today. So it has to be an explicit disable here and enable there. And like I said, hopefully it's going to get addressed in future releases, but definitely not in Tentacle.
Okay, yeah, thanks, Ilya. Got it.
Okay. And then just in terms of review, as Ramana pointed out, that's a huge PR. I think it's 18,000 lines at this point. So we have a couple of items that have been broken out. And I think the idea is, or what we discussed is breaking out, like once it's a bit closer and the interfaces are a bit more stable. We've talked about breaking out, for example, the class methods or the APIs. But again, for that, the interfaces need to mature a bit more, and then possibly even pieces of the replayer changes. It would be good to, for example, break out the changes to the image replayer that is concerned with individual images, because we want ideally to de-risk this as much as possible. We want to any changes to the code that is responsible for mirroring individual images, those need to be clearly isolated and be as small as possible, so that by merging this, this huge change, we don't break anything with regards to stuff that is supported today, functionality that is supported today, which is mirroring individual images, obviously. So I expect the main PR to be kind of sliced into at least 2, maybe 3 pieces. But we'll see how it goes. But just in terms of iterating on reviews and getting it closer to the finish line, something like that will likely need to happen, because GitHub interface, the web interface, just doesn't work for this sort of PRs. It collapses comments, collapses like entire. It doesn't just collapse, threads. It actually collapses like entire sets of comments. And then like if you have a link to a comment and you link on it, at least in some browsers, it doesn't it doesn't unfold automatically, so the link just leads nowhere. And over time, even keeping track of the unresolved conversations on the PR becomes a huge pain. So, like I said, we'll likely do that going forward, but the exact split, the exact pieces that are going to be broken out, I think that's yet to be determined. I think that's all I have to say on the consistency groups topic. Any other questions here? All right, moving on. The next 2 are existing defects in snapshot-based mirroring for individual images, and one is unfortunately, it's pretty much data corruption, where a secondary image can get corrupted. These 2 have been so both making syncing for clones work and making discards propagate to the secondary cluster or to the secondary image. Both of these have actually been scheduled for Squid, but due to some prioritization decisions that I don't entirely agree with, work has been diverted to the consistency group item, and they're still pending. I would like us to address at least the one that involves data corruption in Squid. So making snapshot-based mirroring work for cloned images, because right now, all of the conversations that we have about snapshot-based mirroring, there's always a question: oh, are you intending to mirror clones? If so, it's not going to work. And I would like us to get away from that. There are 2 PRs. Both are in draft state that need their work done in the Squid cycle. There was an issue with built-in LUKS encryption, where the way it works, a copy operation needs to be aware of whether encryption is loaded or not, and needs to have access to the data encryption keys, because what the copy operation effectively does is it takes a block from the parent image and copies it to the clone image, but the parent image may be encrypted with one key, the clone may be encrypted with a different key, or even with a completely different encryption format. So like the parent can be encrypted with LUX1, and the clone can be encrypted with LUX2. So obviously, the copy up operation then needs to re-encrypt the data with the clone image's key. And the way the first version of the fix, like the way it was approached initially, is we tried to like those copy apps were attempted to be performed within the RBD mirror daemon on the secondary cluster. And since the encryption is not loaded there, and nor do we want RBD mirror daemon to have access to the keys for all of the images that are involved, that approach had to be scrapped, and I think that's where that PR is currently at. So it would need to be redesigned to pull the data directly from the image on the primary cluster where it's already been copied up, and have the mirroring operation preserve the property that it's just copying raw bytes and doesn't attempt to interpret them in any way. The the discards not getting propagated properly. What that means is that there's no way to, or it's very hard. It's possible, but it's very hard to, and it requires manual intervention to reduce the space that is used by the secondary image on the secondary cluster. So if a bunch of data got discarded or trimmed on the primary image, that does not currently propagate to the secondary. Like I said, there is a manual workaround, but this is a quality of implementation issue that I would like us to address in Tentacle. And then the remaining two items under the RBD mirror umbrella is the issues with force promote and dealing with the source cluster becoming unavailable, which is kind of related. Those I put them under Tentacle, but that is definitely like a stretch goal because these are long-standing issues, especially the force promote one, the preconditions for RBD mirror image promote force item up there in the pad. That one is a long-standing issue, and it's basically I would call it a kind of a design mistake in the kind of snapshot-based mirroring design. So fixing it is pretty involved, and also reaches into some of the what some might call technical debt for RBD, where we don't support canceling operations. The only thing that we have is a blanket timeout that can be imposed at the radius level, and then there is nothing within librd that could cancel and a running operation. This ties with the source cluster becoming unavailable. So if that happens, the image replayer pretty much just hangs within the RBD mirror daemon. Like if it happens, like not always, so that there are some scenarios where it is able to shut itself down, but in the general case, the worst, like in the worst case, it's just going to hang until the connectivity is reestablished, which may not happen at all in case the primary cluster is in case there's been a disaster and the primary cluster is gone for good. There is some work by Prasanna to at least enable that blanket timeout that we have. So there was a PR. Unfortunately, it's lacking any tests. So that might be kind of an isolated unit of work that can be picked up for Tentacle. But overall, like, it's very likely that this is not going to get done in Tentacle, but I would like us to make some progress in this area. So that's why I put it there. And then there is a long tail of RBD mirror related kind of items and improvements that are at the end of the pad, which I've explicitly labeled as out of scope for Tentacle. But it's something that was discussed in previous CDMs. But we don't really have the resources to work on any of them. So moving on from, well, any questions or any comments on the RBD mirror section?
Yeah. The last one, give up if the source cluster becomes unavailable. Can you please explain? I didn't get that. Means in which situation?
It means that, like, if the connectivity suddenly goes away, like if there's a disaster and the source cluster becomes the source cluster is just destroyed, or if it's just a temporary network hiccup where the source cluster simply becomes unavailable for some time in terms of connectivity. So you simply can't connect to any of the daemons, like it's not reachable. Then this is the scenario that this item is talking about. Currently, like I said, the behavior is that in some cases RBD mirror daemon is able to, or the imagery player within the RBD mirror daemon is able to shut itself down, but it's not universal. And I would actually say that in most cases, if it's an IO request, like if it's a read, like if it's in the middle of syncing a snapshot and it's reading some data, and if that read request hangs, like if at that exact moment the connectivity goes away, then that read request would just hang. That's the current behavior. And as you can imagine, that's from the quality of implementation perspective, that's really not okay.
So source cluster we're referring as primary cluster.
Yes.
Okay.
Anything else?
Yeah, nothing. Thank you.
All right. So the next kind of bucket of work for Tentacle is improvements to LUKS encryption and the associated improvements to line migration. I've tried to separate them still, to the kind of the PRs and the tracker tickets that pertain more to encryption than migration into the second bucket, and then the items that are kind of make sense on its own without encryption involved into the third bucket. So starting with the built-in LUKS encryption improvements, there's something that all emerged just a couple of weeks ago, where the reads from an encrypted source did not work. So like we literally did not decrypt anything and simply returned raw data, meaning ciphertext, to the user in this case, while migration is in progress. So after migration completes and the image is, the image is fully there on the destination cluster, then the issue kind of suddenly the issue just silently resolves itself. But for the actual aspect of the migration being live while it's in progress, this is what happened, and that's now fixed. We are the data is correctly decrypted, and plain text is returned to the user. The next item is preserving sparseness while reading from encrypted source. It's related to the to making reads work at all, because previously the bugs that are that are related to sparseness were not visible because reads just did not work, period. Now that they're working, we have a tracker ticket for actually preserving sparseness and differentiating between the blocks that haven't been written, so the blocks that aren't allocated and therefore do not need to be decrypted, and then the blocks that have been written to and therefore need to be run through the decryption engine. So that's what the preserve sparseness item is about. Sunil, I think you had your hand raised.
Yeah. Regarding that first one, make read from encrypted source, like once the encrypted image got live migrated, any migration works done, and then from the destination image, does it in the encrypted format or it's in the user readable format?
Well, the data that is migrated is encrypted data. So what is, like, physically what is migrated is ciphertext. But then on the destination, both while migration is in progress, that's the bit that previously didn't work, and after migration is completed, that's the bit that has always worked. The user is able to load encryption, which meaning open the image and supply the keys, and once they do that, they're able to access plain text data. If they don't supply, if they just open the image and don't load encryption, don't supply the correct passphrases, then they would get ciphertext, and that's not related to migration. It's the same, like it works the same way for on the original source image. It works the same way on for example, DMCrypt. So if you have a block device on top of which you layer DMCrypt, if you read from that block device directly, you get ciphertext. If you read from the DMCrypt device, which was successfully opened, meaning that the correct passphrase was supplied, you get plain text data.
Okay, got it. Thank you.
Yeah. So RBD here, like this has been closely modeled around DMCrypt, and in fact, if you don't involve clones, like for standalone images, we are actually compatible with DMCrypt. So you can literally map the block device, map the RBD image, and then load DMCrypt in it. So don't load encryption at the librd level, but load DMCrypt on top of librd, and it would still work. It would return correct plain text data, because it doesn't work for clones, but for standalone images, we are fully compatible.
Okay, means for clones, if the data is encrypted, it's going to use the same keys, encryption keys.
No, it depends on the user. So if the parent image can be encrypted differently from the clone, or rather the clone can be encrypted differently from the parent. The parent may also not be encrypted at all, but
okay,
the user may choose to encrypt the clone still. So the use case would be, like, for example, a golden image, which is just like an image of Fedora or CentOS, which you use as a starting point for your virtual machine, and then that you don't have, like, you don't have anything to protect there, because it's just downloaded from the from fedora.org or something. But then your clone, where you actually make adjustments, put your put your own configuration there, install your applications that you want to encrypt, and you can do that. The parent image can be plain text, and then the clone can be encrypted however you want. LUX1, LUX2, with whatever passphrase and with whatever options.
Okay, so here user has the option to choose to encrypt or not, whatever way he wants.
Moving on, there is an issue with discards that is kind of similar to discards not being propagated to the secondary image here. This is an area where, deencrypt, for example, by default does not allow discards on LUX images. And initially, we did the same for RBD, but that's people are starting to complain about that. And since kind of the attack or the kind of the security concern that that the LUX maintainers had originally, while it is valid, it doesn't seem like something that we should be religious about here. We want to so we want to at least give that option, because right now discards are simply not passed down to the object store, and therefore a LUX encrypted image can only grow in size and can never shrink. That involves, there is an old PR that attempted to kind of do this, to do there is a low-hanging fruit there where you can pass down discards only if it's a full object discard, and that would get us kind of some of the way there. But the real, the proper fix here would be to divorce discard and write same handling, because write same is something that even if the user requests like a single byte to be zeroed or some byte to be written, that's something that we need to do. We can punt on that. Whereas if the user asks us to discard one byte or just some unaligned block that doesn't make sense, then we can simply punt on that discard. So right now, the handling of discard and write same, it's divorced for on the core IO path, but it's intermingled for the encrypted IO path, and that's what needs to be fixed here. And then finally, there is an issue where we return inconsistent results on reads, and this has to do with again kind of preserving sparseness. So all of those items across the buckets, are kind of related to each other. There is an issue where we currently lose the sparseness information for smaller reads, and return inconsistent results to the user. These are reads from unallocated areas, so the fact that results are inconsistent on the one hand is not that big of a deal, because this is an area which hasn't been allocated. There's no defined data there. But on the other hand, there are there are different standards in the storage world that actually require the data, like the pattern, to actually be defined, even if the block hasn't been allocated. So we want to improve our behavior here, and the simple fix, at least for replicated pools, is to enable sparse reads unconditionally. So right now it's a threshold, and it's set to 64K. So any read that is less than 64K, by default, that read is processed kind of directly in a non-sparse way, and that's where the issue is. I think historically there's been some concern about sparse reads being potentially having some overhead, and therefore they were deemed, like, for regular images, like without encryption involved, as just an optimization where we want to avoid transferring a bunch of zeros on a read over the wire. So a threshold there makes sense. But for encrypted images where sparseness information is not really an optimization and more or less required, that needs to be. I think we simply need to change the default there, but we'll see. I think that's it for this bucket. Any comments or questions here? All right, moving on. So pure live migration improvements. The first one is support for importing an image from another Ceph cluster. So currently we support live migration between pools within the same Ceph cluster, and also within the same pool, like an image can be live migrated to, for example, change its layout or change any of the options that can only be specified at image creation time. This is adding support for importing, not migrating, because it's live migration in import only mode. That's the official wording in the documentation. So there is a ---- import -only switch, which gives access to the various external kind of sources, such as raw files stored like on a POSIX file system, or an S3 object in an S3 bucket, or something that is accessed, just a file that is accessed by HTTP. There are various options there. And we are adding an additional option for an external data source, where this data source is actually an image in a Ceph cluster. There is a difference in kind of semantics here. When an image is live migrated within the same cluster, it's actually moved, so the source image eventually disappears, and the destination image fully replaces it in the new location. In this case, when it's in an import-only mode, and nothing happens to the source image, and it just like a new image goes up on the destination. So this PR here, which is very close, it's adding support for that. And then the next thing in this bucket is adding support for an NBD format /stream. So we have this distinction between formats and streams. So we support a raw format, which is like a fully allocated, fully allocated file, and then a QCOW2 format, or QCOW1 is also supported, but people mostly care about QCOW2 these days. So we support that on the format side, and then POSIX file, HTTP, and S3 on the stream side. So there's kind of a difference between a format, which is an actual like layout of the file, and then a stream, which is how that file is accessed. NBD is a bit of a weird kind of kid on the block here, because it's a mix of a format and a stream, where it's accessed like you access a socket, which is exposed by the NBD server, and then the format it's really a raw format, but it's accessed via NBD primitives. There is a PR for that that should land in the coming weeks. That's one of the set of PRs that I've taken over from IBM Research, who initially contributed these, like many of these improvements to LUKS encryption and live migration. And then there's a tracker ticket here. I suppose I missed the title, but it has to do with the defect where when migrating from a clone image, if there's encryption involved, you end up having to pass the encryption spec twice due to how the code works. That's something that should be pretty easy to fix, and we will definitely attend to it in the Tentacle cycle. Sunil?
Yeah. So this live migration is actually one plan for Squid. So the base of the feature will be delivered in Squid, and then like improvements will be taken care in the Tentacle.
No, Squid has already frozen. Squid frozen back in March, actually. So at this point, these features were originally planned for Squid, but unfortunately, there was no progress made by the original contributors on them. And so for Tentacle, decision has been made that we would take over, and so that's what I'm doing. And making reads work, making reads from encrypted source work on migration that has already landed. The support for importing an image from another Ceph cluster should be landing this week. And then the NBD stream thing is the last of those kind of big ticket items that have been taken over that will be landing in the next 2 to 3 weeks, I would expect, possibly a month.
Okay.
But these are all Tentacle. These are all Tentacle items. And this is a meeting about Tentacle, so let's not talk about downstream here.
Okay, sure.
All right, moving on. There is an improvement to defederate API in the RBD to make it work with non-user snapshots. Non-user snapshots, these are in particular group snapshots, but also mirror snapshots, and also snapshots that have been moved to the trash. So we have 3 types of non-user snapshots, which are currently hidden from the user. In a way, so we did kind of too good of a job hiding them when they were introduced, and they're hidden so well that the RBD disk usage command, which is supposed to report disk usage for an image and all of its snapshots, actually just skips them and does not report, so it does not account the space that is used by those snapshots. But despite being non-user snapshots, in the sense that they are created by, it's not, they are created indirectly, not in response to an RBD snap create command, but in some different fashion. So it could be, RBD mirroring, creating a mirror snapshot, or it could be when a group snapshot is taken, a corresponding snapshot is taken on the image. That's something that I've talked about for one of the previous items. And finally, when the snapshot is moved to the trash, all these are kind of indirect actions. Those snapshots still consume space and can actually consume, just like any snapshots, can consume space that is as big as the image itself, because if the image has been fully overwritten after the snapshot was taken, then the snapshot, it's a copy and write snapshot, so it's going to consume exactly that much space, exactly the kind of image size worth of bytes. So that's a gap that needs to be addressed, both to make RBDDU commands actually provide that information to the user, and also to fix some issues in the dashboard. And it's possibly also going to be used for implementing a change block tracking feature on the Kubernetes side in Ceph CSI. So at least 3 use cases for this, and we'll definitely address it in Tentacle and also backport it to all supported releases. And then finally, the 2 items on the kernel client side that I mentioned, neither pertain to RBD directly. These would be changes to the libsep module, which is kind of the equivalent of libradus in the kernel. So once they're implemented, both RBD and CephFS kernel clients would take advantage of it. The upmap read balancer hasn't been particularly stable. It landed, like the building block for it landed in Reef, and then the actual balancer piece landed in Squid. However, it's tied to the server Reef feature bit, and that only happened recently. So the kind of the backwards compatibility story was missing there completely. So now that that's fixed, and there are still some, I think, fixes in flight to, for example, clean up stale PG upmap read mappings, or PG upmap read kind of entries in the exception table, in the corresponding exception table in the OSD map. Currently, like, for example, when the pool is removed or when the balancer is disabled, even, I think there is a potential for those items to be left in place and go stale. So with all those fixes in place, adding this to the kernel client makes sense. So I think I'll work on that. And the other thing is something that landed in Squid, support for crush multi-step retry rules. This is useful for, this is going to be used for some erasure coding setups. There are some combinations of K and M erasure coding kind of values or parameters for which existing crush rules kind of don't really work, produce suboptimal results. So this would enable using the kernel client in those setups. And I think that's all we have kind of planned for Tentacle. Prasanna, if you scroll down in the pad, we have a section. We have a section with items that are explicitly out of scope for Tentacle. The only, well, I mean, some of this can be, so for example, if someone picks up the QA suite migration to Ceph ADM, there's been some renewed chatter about it recently, with regards to potentially, doing as much in containers as possible to make transitions between distros easier. RBD Suite currently, is fully package based, so it uses the old way of installing Ceph. Changing to Ceph ADM should not be a big deal. There was an old PR that I've added here for reference. So if someone wanted to do that, we can obviously take it into Squid. The same goes for persistent reservations for Windows. Like, no one on the RBD team per se is going to work on it, but there is this is something that a contributor from Cloudbase has been working on, and I think they're working on a kind of a new approach to it that is going to be more reliable than what is currently proposed in the PR. So if that happens in time for Tentacle, then that would be taken in as well. But none of the I don't think we have capacity for any of the RBD Neo items here. And I think that's all I have. We're only slightly over time. Are there any questions, comments, concerns with this kind of scope of work? Anything at all? All right, I'll take that as a no. Thanks everyone for attending TDS. And we'll see you in the channels.
Yeah. Thanks, Ilya, and everyone.
Thanks. Bye.